All right, so I'm just going to quickly go through some of the examples here. Now, this is looking at stuff I did for the previous video. So to get rid of it, you can either go to tab and delete things, but I find it so much easier just to go to your home screen and just go to new document. And obviously you don't want to save it. I mean, who wants to save maths work that they continually do? Well, I probably shouldn't say that as a maths teacher, but you're just going to end up with a lot of junk, and you don't want a lot of junk in your calculator because the memory will go. All right, so for this worksheet here, you need to determine the y-intercept, x-intercepts, if there are any. So remember, not all parabolas have x-intercepts. Coordinates of the turning point and the y-coordinate when x equals 1. Now, the reason why we want to do D is because if you don't know if there aren't any x-intercepts or you don't know what they are, you do need features of the graph to help you draw your parabola. So usually we can use the y-intercept, the x-intercepts, and the turning point, but if your graph has no x-intercepts, then you kind of need another point to show that you've drawn it accurately, because your graphs can be anything really, unless you actually state what the values are. Okay, so let's have a look at the first one. We can type it in exactly how it is written on the sheet. So x plus 1 squared plus 1. Now I can see straight away what the turning point is, okay, because this is in turning point form. But we're not doing that until the next sheet. But if you are interested, I'll just quickly go here. That's finding the turning point of a quadratic. Okay. All right, so let's just, press enter on the wrong thing. There we go. Okay, so this one here, we don't actually have any x-intercepts. So let's start with our y-intercept. I can see clearly that it goes through y equals 2. But let's just, actually, no. I'm going to go back, sorry. It's quicker to do without your calculator, the y-intercept, because your y-intercept is just when x equals 0. So if I was to put 0 here for x, it's just going to be 0 plus 1 squared plus 1. So it's going to be 1 plus 1, which is 2. So a lot quicker to do y-intercept without actually doing any calculation on your calculator. All right, there are no x-intercepts, so moving on to see the coordinates of your turning point. So hopefully you remember, went to the wrong thing, menu, analyze graph, it is a minimum. Okay, so remember when it's down the bottom, it's a minimum. Okay, so your turning point is -1, 1. And your y coordinate when x equals 1. Okay, so let's just go to menu. Trying to remember how to do this. I think graph trace, and we can just type in 1. And you can see down the bottom here, it's done the point for you. Let's see if I can just put in another point. So let's try -2. Okay, so graph trace, trace, graph trace, and it'll just allow you to put in any value you like. So we had to do x equals 1. You can kind of see the x there. X equals 1, y equals 5. And that's basically the same as plugging it in here. So 1 plus 1 is 2, 2 squared is 4, plus 1 is 5. So that's where the 5 has come from. So when you're sketching your graph, you now have 3 points. Okay, you've got the turning point, you've got the y-intercept, and you've got this point here where y equals 1. If you wanted to, you could also do another point on this side so that your parabola is symmetrical. Okay, but basically having those 3 points satisfy that you understand, or you can draw the equation. All right, let's do another one. So let's delete this one here. All right, I'm going to do one. Okay, so the next one actually crosses the x-axis. Oops, plus 2 squared minus 1. So I can look at these equations and know which ones actually cross the x-axis. And that's what you need to aim to be able to do, is to look at them and say, well, I know what is happening with this quadratic, and I know whether it's actually crossing the x-axis or not. So you can see here it's crossed the x-axis. Okay, so see how there's a +1? Okay, that meant that the graph moved up. This -1 meant that it moved down 1. So this went up 1, which then moved it above the axis. This one went down 1, which meant it went below the axis. So what do you think is happening here? Yeah, it's moved up 2. Does it have x-intercepts? No, it doesn't. Neither does this one. Neither does this one. This one does because it's moved down. G, we've got a positive here, but we've also got a negative here. So this one actually crosses the x-axis, and we might do this one next as another example. Okay, so let's move on. Your y-intercept, I can see there is, let's just move that out of the way. 1, 2, 3, let's just check. 2 squared is 4, -1 is 3. Fabulous. So I know that the y-intercept is 3. Another thing you can do, which I just realized, graph trace. If you wanted to, you can do x equals 0, and it's put it there for you. Okay, 0, 3. Just while I'm there, let's do x equals 1. Okay, is 8. You can substitute it in there also. So if I had 1 plus 2 is 3, 3 squared is 9 minus 1 is 8. So that's all good. Your x-intercepts, oh, it looks like it's going through -1, -2, but let's just check. What are we doing? 0. Okay, there's 1. Yep, -3. 0. And I think that might be our turning point. Let's just move you out of the way. No, that wouldn't be our turning point. I don't know what that point is there, because I know just by looking at the graph that it's not our turning point. Oops, looks like I've actually got a point on there. Anyway, let's move on. Minimum. So we go to the left, then to the right. It's -2, -1 for our turning point. So when you sketch this, you've got 4 points now. Oh, you've actually got 5. We've got 2 x-intercepts. We have this turning point. We have our y intercept, and we also had the y coordinate when x equals 1, which was 8. Okay, so you can use those points to help you sketch your graph. And when you're sketching your graph, you should actually write these points on here. So if there's anything that's crossing a scale, obviously you can just, crossing an axis, you can just draw it on your scale. But your turning point you should put on your graph, and also the y coordinate when x equals 1. All right, let's do the last example. So I was going to do, let's just see, what was it, G. So we have, oops, got to put the negative out front, x minus 1 squared plus 3. Okay, so this graph here, I can't really see it. Okay, you can see the features of this graph, everything that we need, but it's a bit messy, isn't it? And then we've got all these other values on there. So if you want to delete things, press Control, and in the middle here, you'll see a hand, okay? And it just means it'll clench your fist and be able to move things, and also be able to grab things to delete or move if you wanted to. Okay, I'm just going to move that out of the way too. You can also change your window if you wanted to do it that way. Okay, so the more practice you have with your calculator, the more confident you're going to be with it, because some people freak out about the calculator, but it's not really that scary. I mean, you guys use iPhones and iPads, which are probably a lot more complicated than the calculator. All right, let's move on. So y-intercept first. Let's do it using the graph trace. So let's 0. Okay, so your y-intercept is 2. While we're here, let's do D, the y coordinate when x equals 1. So that's 3. Also looks like it might be the turning point. Okay, so let's do the x-intercepts. Sorry, all over the place. 0. Okay, so there's your first one, -0.732. And the other one, 2.73. and then your turning point. So it's a maximum this time. 0, 1, 3. Okay, so enough points there for you to be able to draw your graph. Just remember this should be below -1, and this one should be just below, sorry, to the, you know what I mean. So you should draw it roughly where it should be. So when you put it on your graph, you can actually just write the point where it crosses, -0.732 and 2.73. But if you actually are drawing a scale, make sure that it's before -1 and this one's before 3. All right, I'm going to leave that video there. There should be solutions for all of these, or if there isn't, you should be drawing them on your calculator anyway, so you don't really need the answers as well. Okay, bye-bye.